Okay, in this video we're going to go over the review for 7.5. So in this section we've been working with trigonometric functions of sine, cosine, and tan. Okay, so you want to say sine, cosine, and tan or tangent. Okay, so in your own words, what does Sohcahtoa tell us about our trig function? So what I was looking for, I wanted you to say is that Sohcahtoa reminds us that the sine of an angle equals opposite over hypotenuse, and that the cosine of an angle equals adjacent over hypotenuse, and lastly, the tan of an angle equals opposite over adjacent. And in terms of the angles that we're talking about, we are speaking about the two acute angles in a right triangle. Okay, so you will never take the sine, the cosine, or the tan of the 90-degree angle. It's always going to be the acute angles. Okay, to go on. When finding an angle using tangent, do we use tan or tan to the -1, also called the inverse of tan? And that's what we use. Whenever you're looking for an angle, you will use tan to the -1 if you're using the tan function. So draw your triangle and demonstrate how you would find an angle using the tan function. Okay, so I would draw a right triangle. I would name this angle A, and why don't I just give these two sides some values? Okay, so then to find A, I would say tan of A equals opposite, because from angle A's perspective, 3 is the opposite, over, from angles A's perspective, 7 is the adjacent. So therefore, angle A is going to be tan to the -1 of 3/7. Okay, that's how you say it, and that's how you write it. You would put that in your graphing calculator, and why don't I do that so I can get an answer that you can verify. Second, tan to the -1, look at your screen, make sure it says tan to the -1 of 3 divided by 7, and I'm getting an angle rounding to the nearest tenth of 23.2 degrees. So in this situation, my A equals 23.2 degrees. Okay, our mode is always going to be degrees. Okay, let's go on to the next page of my notes here. Okay, so 3 says when finding a leg of a triangle using sine, do we use regular sine or sine to the -1? You use regular sine. So I go on to say, so you only use the inverse trig, which is the -1, when you are looking for an angle. Looking for sides, you use either sine, cosine, or tan. Okay, draw your own triangle and demonstrate how you would find a side using the sine function. Okay, if I said this is angle A, and why don't I make that 40 degrees, and I'm going to say that this is X, and this is 35, we'll say. Okay, so if I'm going to be using angle A, I would say sine of A equals opposite. From A's perspective, this is the opposite, and the hypotenuse is always, always, always opposite the 90-degree angle. So Sohcahtoa is telling me that sine is opposite, which is the X, over hypotenuse, which is the 35. Okay, now I'm going to make a correction right here. I can't have two unknowns, and that's why I gave this angle a measurement. Okay, so do your cross products. That means this times this, so 35 times the sine of 40 equals X times 1. So we always use cross products when trying to find a missing side. In your graphing calculator, let's put this example. 35 times the sine of 40, not sine negative 1, but just sine, and I'm getting x equals, rounding it to the nearest tenth, 22.5. So you should be verifying this with your calculator so that you also get to reinforce your rounding. Using a trig function and showing all work, find angle A. Okay, here's angle A. I'm looking for the angle, so I'm going to use inverse trig. I have the opposite, and I have the hypotenuse. So if I'm remembering Sohcahtoa, the second I say I have opposite, I check here. I have hypotenuse, I check here. This is the only one that gets 2 check marks. I must be using sine. So sine of this mystery angle A equals opposite 12 over hypotenuse 17. I always use inverse trig to get an angle back, and plugging that in my calculator and rounding to the nearest tenth, I am getting 44.9 degrees. Okay, let's go on to the next problem. Okay, 5. Now I'm going pretty quickly through this, but since it's a video, you can stop it and go back over what I'm saying. Okay, you don't have to go as fast as I'm going. Just stop, look at what your paper was, what you had written down, reconcile that with what I'm saying, make notes if you need to, and then move on. Don't let me pressure you by the speed at which I'm going. Okay, using a trig function, find x to the nearest tenth. Okay, so I look at my figure. Here's x. I see that I have an angle here. X is its opposite, and I have the hypotenuse. So again, you should always be doing the Sohcahtoa so that you are using this little map. Okay, so I said that x was opposite, and I also had the hypotenuse. Once again, sine's the only one that has both things checked. So sine of 27 equals x over 30. I'm looking for a side. I'm going to do cross products. 30 times the sine of 27 equals x. This is called a one-step problem because I get the answer after doing only one multiplication. So put that in your graphing calculator. 30 times the sine of 27 should give you, rounding to the nearest tenth, 13.6. Okay, look at problem number 6. Here's my angle. It says find x. So I see that from this angle's perspective, x is adjacent, x is hypotenuse. Okay, so that's the hypotenuse because this is across from the right angle. And the 50 is adjacent. Okay, so I'm going to write Sohcahtoa again. Okay, so I said that x was the hypotenuse. So here's hypotenuse, and the 50 was the adjacent. So only cosine has both things checked. So the cosine of 33 equals adjacent is the 50, hypotenuse is the x, which is missing. Do your cross products. And I get x times cosine 33 equals 50. This is a two-step problem. Divide both sides by cosine 33. I'm just going to do it like this to save some space. And put that in your calculator. And I am getting to round to the nearest tenth. X is 59.6. Okay, moving on to number 7. So 7. Okay, it says solve for a to the nearest tenth if the sine of a equals 0.2456. So I know that a is an angle. To get an angle, I am going to take the sine negative 1 inverse trig of 0.2456. It doesn't matter whether you represent the sine of the angle as a fraction or a decimal. You still use your inverse trig to get back the angle. And I'm getting to the nearest tenth, 14.2. Do the same thing here. Now it's cosine. Use inverse cosine to get yourself the angle. Put it in your calculator, take it to the nearest tenth. You should be getting 41.4. This time we're using tan. We need to find C. C equals inverse trig. Looking for an angle. Put that in your calculator, and you're going to get 53.4 degrees. Okay, make sure you're doing this along with me so that you can verify the rounding piece of this as well. Okay, number 10. Looking at 10, I tell you something very important. I tell you that the cosine of angle C is 6 over 10. Here's angle C. What does cosine equal? Well, cosine is, we'll do the whole Sohcahtoa again, so I'll cross that out. Go back. Sohcahtoa. Okay, so cosine is going to be adjacent over hypotenuse. So the adjacent must be the 6. The hypotenuse must be the 10. I do not have that value over here. First, I want you to solve for your angle. If the cosine of C equals 6/10, then C must be cosine -1 of 6/10. Put that in your calculator, and you should be getting 53.1. So I'm going to label this 53.1. Everything's to the nearest tenth. Now solve for A. So why don't I change my color, and I want to solve for A. So I want to figure out what I have. Well, I have the opposite, and I have the hypotenuse. That is sine. So the sine of angle A must be 6 over 10. To get the angle, I'm always going to use my inverse trig. Rounding to the nearest tenth, I'm getting 36.9 degrees, and I'm going to label it right here. Okay, so I have both of my angles now, and I'm just missing the side. So the next thing it says, now solve for the missing side. That's X. So I have lots of options here. I'm always going to use my acute angles. So I'm either going to use 53.1 or 36.9. Your choice. I'm going to use 53.1. From that perspective, X is opposite, and I think I'm going to use tan. 6 is adjacent. So the tan of 53.1 equals opposite, the unknown, over the adjacent. Whenever we look for a side, we're going to do cross products. So I have 6 times the tan of 53.1. That's going to equal my missing side. And rounding to the nearest tenth, I am getting 8.0 for that missing side. Okay, let's do 11 on the next page. So here is 11. So they give you this information. This is key. So down here I'm going to write Sohcahtoa. And you should find that you are frequently writing this yourself so that you are keeping track of what you have to do. So if the tan of G, where's tan? Where's G? Right there. Tan is opposite over adjacent. So opposite is going to be 7. Opposite. Adjacent will be 12. Adjacent can't be over here where I'm putting the X because that is the hypotenuse, which is always across from the right angle. Okay, so if I know that tan of G is 7/12, then I know G has to be inverse trig, tan to the -1 of 7/12. Put that in your calculator, and you should be getting 30.3 degrees. Again, I've rounded to the nearest tenth. So let's put that on our little figure here, 30.3. I will change color. Now I want to solve for angle A. angle I. Here is angle I. What do I have? I have opposite and I have adjacent. I don't have the hypotenuse. So opposite and adjacent is going to be tan again. So I'm going to say the tan of angle I equals opposite from angle I's perspective is 12. Adjacent from angle I's perspective is 7. Remember, adjacent always hits the angle. Okay, to get my angle, I'm going to use inverse trig. I started with tan, I stick with tan. I plug that in my calculator, and I'm going to get I equals 59.7 degrees. Okay, next thing we're going to do is find this missing side. So, I can use either angle, and I can use any of the trig functions that will work. The missing side is a hypotenuse, so that means I'm going to use either sine or cosine. So let's use sine. So what if I say the sine of 30.3 equals, okay, sine is opposite. Opposite is 7 over hypotenuse, which is what's missing. Okay, whenever we have a missing side, we're always going to do cross products. So what do I have is x times the sine of 30.3 has to equal 7. Divide both sides by the sine of 30.3. And that's going to give me an x equals 13.9, and we are done. Okay, so you want to go over this and have a good handle on it. As long as you are getting an x of 13.9, you could have done it with a cosine as well. So know that there are a couple of ways to get these answers. Other things you should definitely know is that filling in this angle right here, 59.7, the acute angles, so this guy and this guy, of a right triangle will always add up to 90. So you can help yourself that way. It's a way to check your work. Another thing you should know about the triangle is that the hypotenuse, and in this case it was 13.9, is always bigger than either of the legs of the triangle. If you got an answer like 10 point something, then you should go back and check it, because clearly it has to be greater than 12, because that's the biggest side of that triangle. Okay, well, this is a lot to go over, so feel free to listen to it again. I hope you were stopping it and not just listening to it straight through, because that could be very, very confusing. You need to give yourself time to process this information. This is not easy stuff, but we've been doing a lot of work with this, and many of you are really doing awesome with it. So you just have to practice and think about what you're doing, and you'll be fine.